So what do concentrated solar plants actually use? Well, the most common is solar salt, hence the name. It's a good compromise. It has a decent efficiency because of the high temperature. The material, solar salt, is fairly cheap. It stays liquid. It doesn't need huge storage tanks because it can store quite a bit of power energy in one place. Not too corrosive. So here's how a concentrated solar plant based on hot salt will work. So you get the heliostat mirrors. You need enough of these things to raise your central area to close to the melting point of the solar salt. Then up in your tower in the middle, you're going to have some sort of pipe that pipes the cold solar salt through it, which is exposed to this enormous heat, and so you get cold solar salt coming in the top and hot solar salt coming out the bottom. And you have to design this carefully so the heat comes in and has the right effects. You then put the hot solar salt in one of your tanks, and you store it until you need it, which might be that evening when everyone's turned their kettle on and the sun's gone down. At that point, you will pump that hot salt into a turbine, into a heat exchanger, where it will be used to boil high-pressure water into high-pressure steam. That steam will then go through some giant turbine blade and produce electricity. After the steam has been generated, the cooled salt is stored at 290 degrees centigrade, put in the cold tank, ready to be used again the next day. And this is how things work, and it seems to work pretty well. There is actually an alternative being pioneered by an Australian company called Raygen, which at the time of writing had just started their first plant at a place called Carwarp in Western Victoria. Some people are thinking this might be a way of the future. It's not widespread at the moment, but it's an interesting difference from the hot salt that I thought I'd talk through. What they have is heliostats, but rather fewer of them because they don't want their solar panel in the tower to be so hot. What happens is when all the sun is focused up here, it only brings it up to about a temperature of 100 degrees because you're using water to cool it, not the salt. But there's also in there, next to the water, an actual solar panel, a photovoltaic panel, but a really good one. Because your panel is only quite small, you can afford to spend a lot of money on having a highly efficient one, and so these are more like 30% efficiency rather than the 25% or so that you typically get. So you get electricity from your solar photovoltaics, and you heat the water up to near 100 degrees. And you don't need so many of these heliostats because you're not getting it so hot. What do you do with the water? Well, you basically store it in a big hole in the ground. Here's the big hole in the ground. It's a pit with insulation on top. So storage is really cheap. You don't need fancy tanks. You just dig a hole and put hot water in it with some insulation on top. And then you use a Rankine cycle heat pump to convert the heat at some later stage from this hot water into electricity. You actually have two tanks, one containing hot water and one containing cold water, and they're both big pits in the ground, and you use the electricity from the solar photovoltaic cell to keep the cold water cold, because of course it could otherwise get too hot, and that gives you the bigger energy temperature difference and so generates more electricity. And at the moment this is quite small scale and fairly expensive. This is a pilot one, but the idea is in the long run it could be very cheap because it's using water. Water is cheap and easy to handle. You don't need special pipes to handle boiling water. I mean, every house has a kettle that can do it. Storage is really cheap. A big hole in the ground with insulation over the top. It doesn't get much cheaper than that. So the whole thing, the piping and everything is much more simple because you're dealing with water, not salt that will kill you if it falls on top of you. The heliostats are also designed to be very simple. You don't need as many of them because you don't need to get it as hot. And these are actually designed not to need any cabling. They've actually got a photovoltaic cell on each heliostat that gives it enough electricity to drive itself, and it doesn't need to be too accurately pointed. So the idea is to make the whole thing really cheap. Of course, your efficiency is low because you're only dealing with a 90 degrees C temperature difference, and water at 100 degrees doesn't give you a high Carnot efficiency. But the hope is that by making everything else so cheap, it can still be a competitive form of energy.